Dear students, in this paper on fertility, let's focus on the module titled Standardized Fertility Rates. The broad learning objectives of this module contains the definition of standardized rates, various formulas related to standardized fertility rates, the total fertility rate, TFR, cohort fertility rate, gross reproduction rate, net reproduction rate, age standardized rates, users and uses of birth statistics, replacement level of fertility. The situation and development of fertility or the area of reproduction is an important indicator for demographic and epidemiological considerations. Fertility measures are ratios to characterize the extent of renewal of the population by births, referred usually through birth rates. We have to differentiate between period measures which collect births and live births in a chronological cross sections, for instance months, years, 5-year frame, and second category is cohort measures which pursue births in the course of a woman's life, usually referred as a longitudinal surveys. Let's focus on various definitions adopted in this standardized rates. Standardized rates are a statistical measure of any rates in a given population. These are adjusted rates that take into account the vital differences between populations that may affect their birth rates or death rates. The most common are births, deaths, unemployment rates, etc. For example, in a community which is made up of primarily young couples, the birth rate might appear to be high when compared to that of other sections of populations. However, by calculating the standardized birth rates, that is, by comparing the same age group in other populations, a more realistic picture of childbearing capacity will be developed. Both crude birth rates and general fertility rates are affected by variations, usually in the age structure. This is because fertility levels varies to a great extent with respect to age. This problem can be overcome by using standardization to calculate standardized fertility rates. The only variation in age structure which affects the crude birth rate and general fertility rate are the variations within the childbearing age range. These are usually less in magnitude than the variations over the whole age range, that's between 0 and 120 years, which affect single figure indices of mortality. Thus, standardization is less commonly used with respect to fertility rates than with respect to mortality rates. One situation in which the standardization has been widely used in the context of fertility rates arises in the historical demography of 19th century of Europe. In the most 19th century, European population on data by birth, by age of the mother, they are not available, so age-specific fertility rates were not to be calculated. Regular census, however, enabled us to know the age structure of female population and the total number of births which is normally available. These are precisely in which the standardized fertility ratios can be calculated, provided a standard population, age-specific fertility rates of which are known and they are to be reliable and can be chosen. Cole 1966 had the idea of choosing a standard population, the population with the highest reliably recorded fertility rates ever. Let's look at the formula. The formula for standardized rates are as follows. Sigma of crude rate for age groups and times standardized population for age group divided by sigma of standard population. Standardized fertility rates usually calculated as the average of age-specific fertility rates. The 30 age groups, that is usually the reproductive age group of 15 years to 44 years, which is a reproductive lifespan, are weighted by a standard population that is standardized. The figure is reported per 1000 women. Let's also focus on standardized general fertility rate. For comparison of general fertility rates of the population in different areas, the standardized method is used in order to avoid the effects of differences in the age composition of each subgroup of population, where age-specific fertility rate for age groups x to xn, x plus n of a subgroup of population is equal to the number of females in the same age group in the standard population. The standard used was the number of females in the whole population. Let's look at the calculation for total fertility rate, usually referred to as TFR. Total fertility rate is the sum of the age-specific birth rates, that's 5-year age groups between 10 and 49 for female residents of a specified geographical area, whether it can be a nation, state, country, and other similar geographical regions, which is during a specified time period, usually a calendar year, multiplied by a constant of a 5-year interval. Note, this rate estimates the number of children in a hypothetical cohort of 1000 females in the specified population, which would bear if they all went through their childbearing years experiencing the same age-specific birth rates for a specified time period. Note that this rate estimates the number of children a hypothetical cohort of 1000 females in the specified population would bear if they all went through their childbearing years experiencing the same age-specific birth rates for a specified time period. The calculation is sigma of age-specific birth rates multiplied by 5, where ASBR is each 5-year age-specific birth rates, which is usually defined as BX multiplied by 1000 PX, where BX is the number of live births to mothers age X and PX is the number of residence women age X. The values of age groups represented by BX are under 15 to 19 years, 20 to 24 years, 25 to 29 years, 30 to 34, 35 to 39 years, 40 to 44 and 45 plus years. The values or age groups represented by PX are 10 to 14, 15 to 19, 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44 and 45 to 49 years. The sum of these ASBRs is multiplied by 5 because each ASBR represents a 5-year cohort of women. In terms of the statistics on the natural movement of the population, it is calculated by adding the age-specific birth rates of the monitoring year for women in the age group between 15 and 44 or 15 and 49. It indicates the average number of children a woman would have during her lifetime if the circumstances of the monitoring year would apply from her 15th to 44th years respectively or to 49th year of life. Which value of the total fertility rate is necessary for the preservation of the population depends on the sex ratio of live births and mortality. For the preservation of a population, a total fertility rate of 2.1 children per woman would be necessary. This figure is not exactly 2 because the sex ratio at birth is not 1:1, but only 485 to 490 girls per 1000 births. And because even in highly developed countries, some women who die before they reach the menopause. Also, let's focus about summarized birth rate, that is average number of children per woman aged 15 to 49 years. The total fertility rate, that is TFR, is perhaps the most commonly used standardized fertility measure because it is ideal for a comparative purposes and is a comprehensive summary measure readily understood, at least as a general concept. Like all standardized measures, TFR is a hypothetical and only appropriate for comparison to other TFRs. The theoretical replacement rate for a population is a TFR 2100. This implies 1000 women have 1000 live births to replace themselves, 1000 births to replace their male counterparts, and 100 births to replace those who do not reach or survive through their reproductive years. Sometimes total fertility rate is expressed per woman instead of per 1000 women. For example, the theoretical replacement rate would be expressed as 2.1 live births per woman. Total fertility rate only includes age-specific birth rates for the 5-year age ranges within 10 to 49 years. However, all births to mothers less than 15 years of age and ages 45 plus are included in the calculation of birth rates for the age groups 10 to 14 and 45 to 49 years, while population data in the calculations correspond to the age groups 10 to 14 and 45 to 49 years. Two variations in the 5-year age groups used for calculating total fertility rate are 15 to 49 years and the formerly common 15 to 44 years age range. Comparing total fertility rates by using different age ranges such as the above can result in slight numerical differences. So, one should take note of formula when comparing TFRs from different sources. The total fertility rate can be applied to subgroups of a population based on demographic characteristics other than age and sex. For example, the total fertility rate could be particular to a race category, to a geographical area, or to a marital status and other similar layers, as long as both birth and female population data can be obtained that match for that characteristic. Reporting of live births may differ by birthing facility or attendant at the time of birth. For example, a live birth can be interpreted and subsequently registered as a fetal death or stillbirth when the neonatal period, which is very briefly shows during signs of life and subsequently it may die. In some countries, live births may be defined differently than in the country like US or not applied to the same degree in practice, which is followed by the World Health Organization, which has defined the live birth. In the United States, age of mother is often accurate to the single year of age. Sometimes live births do not become part of the official count of a state's resident live birth total because A. The birth to a state resident occurred in an area, often another country, for which the state does not have vital records exchange agreement. B. The birth to a state resident occurred in an area for which the state does have an exchange agreement, but it arrived to the state's vital registration office too late for inclusion in the state's official count. Or C. The live birth occurred in the state but simply was not registered in time, for instance an at-home birth, for inclusion in the state's official count. Also note that a state's official count of resident live births may vary somewhat from that determined by NCHS for that state due to variations of the above reasons. Now let's discuss about another measurement, cohort fertility rate, usually mentioned as CFR. A cohort is a group of women born in the same year. Cohort fertility analysis explores whether current generations of women of childbearing age are reaching, exceeding, or falling short of the fertility levels of previous generations. It contains statistics on changes in average family size and past and present levels of childlessness for different cohorts of women and the proportions of women having 1, 2 or more children. The other measurement is on gross reproduction rate, GRR. The gross rate of reproduction indicates how many live-born girls a woman of the studied population would bear on an average in her entire life of reproductive stage if the age-specific fertility rate of a certain years is assumed to be constant. The gross rate of reproduction is therefore the total fertility rate limited to the number of daughters. The other measurement is the net reproduction rate. The net rate of reproduction indicates the average number of live-born girls of a woman for whom during her entire reproductive life the age-specific fertility rate of a given year and a specific mortality table applies to this cohort. If the figure is more than 1, the generation of the children is accordingly increased. If the value is below 1, the generation of children is accordingly smaller than the previous generation. In contrast to the gross rate of reproduction, the net rate of reproduction takes into account that some of the women die before the end of their childbearing age. The other measurements refers to age standardized rates, a method of adjusting the crude rate to eliminate the effect of differences in population age structures when comparing crude rates for different periods of time, different geographical areas and or different population subgroups, for instance between 1 year and the next, and or states and territories or indigenous and non-indigenous populations, and such cluster of categories when they are referring, then usually we may have to adopt age standardized rates. Adjustments are usually undertaken for each of the comparison populations against a standard population rather than adjusting one comparison population to resemble the another. Sometimes a comparison of population is referred to as a study population. Population health and health services research is another area of focus that requires our attention. For valid comparisons of rates in different populations such as incident rates, prevalence rates, mortality rates and health service utilization rates, this research focusing on population health and health services are very essential. Let's discuss about the users and uses of birth statistics. It is referred to that these birth statistics produce population estimates and population projections, both national and also subnational. The other aspect which deserves our attention is quality assures that census estimates are to be taken. Reports on social and demographic trends is another aspect which requires an important priority area. Other key users of birth statistics include the Department of Health, academics, demographers, health researchers, lobby groups, international organizations, and of course media. Cohort fertility statistics and estimates of fertility by family size are used by various departments for producing the fertility component of population projections and for reporting on various social and demographic trends. They are also of key interest to academics, researchers who are focusing on changing family building patterns over time. The other aspect requires our attention is on replacement level of fertility. The level of fertility where women replaces themselves with their offspring is an important area of focus. In other words, this is the level of fertility that gives net reproduction rate as 1. The total fertility rate of level 2.1, children per woman in a population, is generally taken as the replacement level of fertility. The replacement level fertility is the precondition of population stabilization, that is a process to achieve zero growth of population. However, if a population attains replacement level of fertility, it doesn't mean the size of population gets stabilized immediately. This takes quite some time and it happens because of population size. In other words, acceleration in population growth persists due to a large number of couples already existing in the reproductive ages in that population. This can be understood by a very simple example of car driving. A driver uses the brakes to stop a car, but it does not stop immediately. It takes a few seconds to stop the car completely because acceleration available in the speed of the car is an important indicator. Let's discuss about parity progression ratios, commonly referred as PPRs. Proportion of women who have already had a certain number of children and go on to have another child, which is interesting and useful measure of fertility. Parity refers to number of children a woman has already had. The parity progression ratio, PPR, is equal to the proportion of women of a given parity divided by who go on to have another child. The measurement has an advantage because PPRs are free of tempo effects, which is no change due to postponement of fertility, and major disadvantage of this is because based on census data, PPRs are cohort measures which are completed or nearly completed fertility, like for instance younger women are not included. The period PPRs can be computed but require data which is not collected in census, for instance like full birth histories which are collected only in sample surveys. So in this we may conclude that the standardized fertility rates are very, very important for us to understand. In this module, to a great extent, it has been focused as we can, through this, we can have a good measurement which is through which we can take into account the vital differences that exist between populations which may affect their birth rates or death rates, and also it will give a rates which can be for comparison across different populations. And as we have seen that there are various standardized methods like total fertility rate, like gross reproduction rate, net reproduction rate, and also there are parity progression ratios which provides a lot of scientific validation for understanding the levels of fertility, and through which we can assess the measurements for a woman in a particular group, in a particular geographical area, in a particular period of time, so that we can have some comparisons and we can establish some trends, and also to compare with a similar situation of the group of community women who are experiencing their fertility measurements in other areas over a period of other schedules, so that such comparison will be much more meaningful when we draw attention for understanding the fertility situations. Similarly, we need to know that such a statistical measurements will be amenable for further analysis of fertility levels and for future estimations also is very important for having such measurements. By adopting these suitable fertility measurements for the population which is given in a particular area, we can have such trends and also to assess the changes that happened, the type of interventions which have brought such changes or scientifically can be assessed, and in this regard the census and the various sample surveys can be appropriately used as data sources for measurements, for establishing trends and to see the differences and differentials over a period of time, which also have a lot of scientific information can be generated as because of the fertility, how best we can understand the overall population situation and also has its immense linkages with the overall development of that particular community.